Normally when there's a new technology, the new version number means that it's better than the previous versions. But the people who named the HDMI standards apparently started smoking something, because from now on, literally everything is going to be called HDMI 2.1, or depending on when you're watching this, they're going to change it yet again to be 2.1a. Even some ancient monitor that's only capable of 1080p at 60 Hz is allowed to say that it has HDMI 2.1, just like the latest 4K high refresh rate monitor. In fact, because they retroactively reclassified the specification, manufacturers have to actually say that it's just HDMI 2.1. They're not even going to have a say in it. So let me emphasize, from now on, seeing anything labeled as HDMI 2.1 tells you absolutely nothing about the capabilities of the device. It's all HDMI 2.1. This means if you go to buy a TV or monitor, you can't just look at the HDMI spec version and get an idea of what the capabilities are. You actually have to specifically look for its individual capabilities and features yourself. Now, device manufacturers that are putting in the latest features are obviously going to be eager to make that clear, but it is still up to you to know all the possible features and look to see whether or not those are in there. Oh, and I should point out it's going to get worse because HDMI 2.1a is coming out and they're going to do the same exact thing. Anything that's now 2.1 will be relabeled as 2.1a. But apparently when that happens, device manufacturers are supposed to just drop the version number altogether and just label everything as HDMI. Totally not confusing. And if you're wondering why in the world they would do this naming scheme, I will go through their supposed reasoning towards the end and explain it, but that being said, it's still stupid reasoning. All right, so here's what you need to know. Like I said, if you see anything labeled as HDMI 2.1, just ignore the number completely. Instead, you're gonna need to know all these new features that were not in HDMI 2.1. And don't worry, I will explain these. Manufacturers are apparently required to say which of these features they do have, but they would anyway. More importantly, they are not required to say which features they don't have. So let's go over these features. First is the current highest speed or bandwidth of HDMI. And this is probably the most important thing for most people because it determines the maximum refresh rate and resolution. I'll explain this one in pretty good detail, but don't worry if you don't understand everything. I'll give you the main takeaway at the end if you just want the fastest speed. Currently, the highest speed HDMI is 48 gigabits per second, and this is labeled as ultra high speed HDMI. At this bandwidth, it supports resolutions up to 8K at 60 Hz or 4K at 120 Hz, and even more if it's using something called display stream compression or DSC. Now, when it comes to cables at least, the good news is a cable cannot officially be called and labeled ultra high speed HDMI if it doesn't support the maximum 48 gigabits per second. So when buying a cable at least, make sure you see that it's advertised and labeled as being officially certified ultra high speed HDMI, and it should also have a label that looks like this. However, I'm not sure if devices also use this naming scheme or whether it's just for cables. And also keep in mind that this name might not be the highest forever, but right now the best one is ultra high speed HDMI. Next time it might be called ultra super duper high speed or whatever. When it comes to devices though, like a TV or monitor, you will want to look at the maximum bandwidth, but there's also two more terms that you're gonna wanna be on the lookout for. These would probably show up on the spec sheet, but one of them is called TMDS or Transition Minimized Differential Signaling, and the other one is FRL, Fixed Rate Link. And just know that TMDS is the slower, older technology, and FRL is the new one. TMDS will max out at 1080p 240 Hz or 60 Hz at 4K, but only with lower image quality called 420 subsampling. FRL is the latest technology, but it still does have levels of bandwidth. FRL was introduced with HDMI 2.1, so you'll know you're at least getting 4K at 60 Hz with the full quality. This is 18 gigabit per second FRL. But if you want the maximum capabilities, look for 48 gigabit per second FRL. This has the same highest capabilities I mentioned before, at least 8K 60 Hz and 4K 120 Hz. So to summarize, if you only care about having the highest resolution and refresh rate, here's the deal. If you're buying a cable, just make sure that the one you're buying is labeled as ultra high speed and make sure it is actually certified as ultra high speed because that means that it was officially tested. If you're looking at a device like a monitor, first look at the spec sheet and make sure it does not say TMDS. Somehow I forgot to say this, but look to see if the device has 48 gigabits per second HDMI bandwidth with FRL, and that is currently the fastest bandwidth for HDMI. If it says FRL at 18 gigabits per second, that's fine as long as the monitor does just 4K at 60 Hertz or less, or 1440p 144 Hertz or less. Okay, so now onto the list of individual features that a device may have, and these are new ones that were not in HDMI 2.1. But also keep in mind that a monitor doesn't have to have all of these. It may have some, but not others. But just remember, all of these are optional, so a device may have all of them, none of them, or any combination. The first we can talk about is dynamic HDR, which is an improvement over the current regular HDR, also called static HDR. Now, as a really quick explanation, HDR, or high dynamic range, just means that you can have really bright things, really dark things, and anything in the middle all on the screen at the same time and all looking good. It also has more shades of each color called bit depth, which means that things will look more closer to real life. Standard dynamic range is 8 bits and has 256 shades or brightness levels per color. And HDR 10-bit has 1024 levels per color. Now, with that context, I can explain that regular static HDR, the peak brightness stays the same for the whole movie or whatever content you're viewing. That doesn't necessarily mean that every single scene will have something that bright as the maximum, but the possibility is there. But the max possible value is set and stays there. With dynamic HDR, content such as a movie has metadata in it that can tell the TV to raise or lower that peak brightness on the fly, whether it's scene by scene or even frame by frame. This is better because with static HDR, whether a scene is bright or dark, all of those 1024 color levels are stretched from 0 to the same peak brightness the whole time. So in a dark scene where there aren't any bright things, those levels in the higher brightness range are being unused, and therefore a lot of potential color information is wasted. But if you can adjust the peak brightness like with dynamic HDR, then in an all dark scene, you can basically focus all the color information only where it's needed. So what is on the screen is going to look more detailed, and especially dark scenes will look a lot less blotchy. It's kind of an oversimplification, but that's the main idea. Now, I'm not sure if dynamic HDR can do the same thing with bright scenes by raising the minimum brightness, but it might. All right, the next feature we can talk about is Enhanced Audio Return Channel, or eARC. With regular ARC, which has been around for a while, in addition to the video going to the TV, it turns one of your HDMI cables into a two-way street and allows audio to be sent back out of the TV through the HDMI cable. Now, why would you want this? Well, it basically saves you from having to run a separate audio cable from your TV to some external audio system like a surround sound system or soundbar. Instead, it lets you send the audio back down one of the cables into the soundbar or whatever, and it will do that no matter what is on the screen, even if other devices are on the HDMI ports. And usually a soundbar will let you plug in and pass through some device, so you can still use that cable as an input on the TV, not just an audio output. It works as a two-way street. Now, eARC is just a better version of ARC. For example, it has higher bandwidth, 37 megabits per second versus just 1 megabit per second of regular ARC, which means it can handle a lot higher quality audio such as uncompressed 5.1 or 7.1 surround sound. The eARC also requires mandatory something called lip sync correction. Now, this was optional for regular ARC, but basically allows your TV to fix audio video syncing issues. I'm not sure if it's automatic or if you have to manually do it always through the TV. I know some TVs do have a setting, but in either case, whether automatic or manual, you will be able to do it with eARC no matter what. I should also mention that eARC has better support for something called HDMI CEC, which is kind of a separate thing, but basically allows you to control devices through the HDMI connection. So you can use your TV remote and use a menu button, for example, or up and down arrows, and control some device, not just your TV, with the TV remote, for example. And apparently with eARC, HDMI CEC will just be more capable and be able to do more stuff, although I couldn't really find many details on exactly what. All right, the next feature is variable refresh rate, and this allows your TV or monitor to adjust its refresh rate on the fly depending on the video signal. This is mostly used for games and actually has been around for a while in gaming monitors in the the form of G-Sync and FreeSync. The main benefit of variable refresh rate, or VRR, is that it eliminates screen tearing, where the image on the screen may literally look split in half because the signal from the video card for the next frame arrived in the middle of the time in which the monitor is drawing the previous frame from top to bottom. With variable refresh rate, the display will be able to monitor the video signal and match the refresh rate to the video signal itself on the fly as it changes. So the frame drawing and video frames themselves are synced up instead of just staying at 60 Hertz or whatever. Anyway, the benefit of this is it makes gameplay appear a lot smoother, particularly when there are dips in frame rate. All right, now the next feature is called Quick Media Switching, or QMS. Have you ever gone to play something on your TV, a video, and for a second before it plays, it just puts a black screen on, and then you have to wait a second, and then it starts playing? This happens anytime you start playing content, whether it's a video or game, that has a different resolution, dynamic range, or refresh rate than what is currently being displayed on the TV, such as a menu. QMS will eliminate that black screen, but only if the only change being made is the refresh rate. So unfortunately, it won't eliminate the black screen if the TV switches to HDR or switches resolution to match the video. But still better than nothing. All right, moving on, we have Quick Frame Transport, or QFT. And this basically delivers frames from the device to the TV faster, which reduces latency. This one took a lot of digging to figure out how this actually works, but it's actually pretty simple. Say you're using a monitor that is capable of high refresh rate, such as 120 Hertz or even 240 Hertz, and you're playing on a console like a PS5 or Xbox, which is set to output at just 60 Hertz, or the game you're playing maxes out at 60 Hertz, whichever. Normally, your TV gets a new frame from the console every 1/60th of a second, then updates the screen over the course of the next 60th of a second until the console gives it a new frame, because it's synced up with the refresh rate or frame rate of the console. But if the TV is capable of displaying at 120 Hertz, what if instead of taking the whole 60th of a second to draw the frame on the screen, it used its full speed to just draw it really fast in 1/20th of a second instead? This is exactly what QFT does. It literally puts frames on the display faster than it normally would, which reduces latency even if the frame rate stays the same. I should point out though that apparently if you're using variable refresh rate, that basically inherently has quick frame transport. Just from its nature, it'll automatically deliver it as fast as possible. So quick frame transport is, I guess, just if you don't have variable refresh rate, it'll still be able to do something. All right, on to the final feature, Auto Low Latency Mode, or ALLM. But remember to stick around after I still have some stuff to explain. Auto Low Latency Mode basically tells the TV to switch to a mode that disables a lot of extra image processing, which then will reduce the display latency. So if you're on an Xbox, for example, it can tell the TV to switch to this because it's a gaming console. And this feature may be called different things depending on the TV manufacturer. For example, LG calls it Instant Game Response. Now, I should also point out that a lot of TVs already have a game mode, it may be called, which is dedicated to having the lowest latency possible. So in some cases, auto low latency mode may just be the TV switching to that game mode that's already there. Now, apparently from what I've read, auto low latency mode, depending on the manufacturer, I guess, may also reduce the latency no matter what picture profile you're in, so not just game mode. But regardless, if you are playing on a device and you want the lowest latency possible, if you use the game mode in the TV, that should probably be fine. Don't worry if it doesn't specifically say auto low latency mode. I think the game mode should give you the same thing. All right, so now you should have a pretty good handle on what all of these features are, so you can know whether or not you even care to look for certain ones, and now you'll know that these are the ones to look for if you do want them. All right, so now let's explain why this whole HDMI 2.1 thing is happening in the first place. Why are they having everything be called HDMI 2.1? Well, you know how a lot of people say organizations and companies can basically go insane if the marketing people all take over and the technical people have no say in anything? Apparently the opposite can happen too. The same thing happened with people who are naming USB, but don't even get me started on that. The important thing to know for context is HDMI doesn't just refer to a type of cable or port. HDMI is also a specification, basically a big document that everyone has agreed will be used to make cables, which are known as HDMI cables and ports. And this specification document also describes all the features and requirements, stuff like that, for anything using HDMI. Now, of course, as technology progresses, the HDMI specification will be updated to accommodate these new capabilities and features. These specification versions will describe the new features, of course, but also integrate most of the stuff from the previous versions for backwards compatibility's sake. For example, it would make no sense for a HDMI cable to only support 4K 120Hz, but not 1080p 60Hz. And anytime they do update this specification, they of course update the version number. So common sense would say that if a device or cable has all the features of a specific HDMI version number, that you should label it with that same HDMI version number. But now enter the pencil pushers who decided to screw everything up. They basically said, well, this HDMI 2.1 specification is the latest version, and it describes not just the new features, but also the old ones. So since this latest version describes everything, let's call everything the latest version. And we won't require everything to have all the new features. Manufacturers can just say on the box what individual features it actually has. So if you want to know if the device you're buying has the latest, most capable HDMI features and specs, then instead of just having to know the latest HDMI version, you have to know every single possible feature and make sure they're all listed on the box. What's that? You've never heard of transmission minimized differential signaling? Well, too bad. Now, like I mentioned, USB did the exact same thing. Everything is USB 3.2 now, but at least they still kept the sub-classifications to differentiate the different speed capabilities, as convoluted as those names are. With HDMI, literally everything is HDMI 2.1. Yes, the HDMI specification actually requires devices to say it's HDMI 2.1 regardless of the features. They may as well just completely remove the HDMI 2.1 at all. And actually, like I said, with HDMI 2.1a, apparently that's what they're doing. Everything will just be HDMI, and that's not going to be confusing. Anyway, hopefully now you'll know everything you need to know about this whole debacle. So let me know down in the comments what you think, even if you just want to vent and say how stupid this is. Also, if you like this video, be sure to give it a big thumbs up. I spent a lot of time on this one. It's probably going to be a very long video, so I'll appreciate it. And if you want to keep watching, the next video I'd recommend is one where I was talking about some new scams. I do one of these videos every year, and these new scams never cease to amaze me, so definitely check that out. So thanks so much for watching, and I'll see you in the next one.